experts, which is Dr. David Alkaher with AmboVent, engineer living in Israel and with a PhD in mechanical engineering and robotics. You've been working on some great designs with a fantastic group. So please, let us know what you've been working on.
Okay, so first, I'm currently a major in the Israeli Air Force, and I'm leading innovation and the Innovation Hub program in the Army. And 2 months ago, I just came back from a trip in Oslo in the Alkaher Accelerator, just giving them a workshop about prototyping and how to, and then just came into quarantine. So after 2 weeks in a quarantine, just came out, and then the whole country came in because we entered the quarantine as a country. And then 2 things happened. First, our government said there is a problem in accessible ventilators. And the second one, we felt there is a fear that Italy would be here. So that took us out of our comfort zone and into an action. So what I did as an innovation leader, I used the most powerful tool, the phone. So I texted everyone that I know, and I called for action for building a portable ventilator. And at first I reached out to the local industry, defense industries and the high-tech industries, but it wasn't it. So I said, the maker movements. So I approached the mentors of the first robotic competition, mentor students, and I think less than an hour, we've built a group of 205 people, of makers, of doctors, of clinicians, software engineers, everything from everything. And the power of this collaboration allowed us to create something very, very accurate, very, very fast. And let's see the presentation.
Okay, we can see it.
Okay. So the whole concept is to build this device, but it's an emergency ventilation alternative system, but using the crowdsourcing approach and open source code mentality, which means everyone can contribute. We prefer that everyone that should be use this device would be participating in defining it. And we tried something new, okay? It's not something that we kind of familiar with, especially in the hardware devices. And wait, okay. So I don't know if you know, but this kind of ventilators is called Plan C, because Plan A was supposed to be what the federal government should do if they were thinking about it in the past, but okay. Plan B is how to accelerate the assembly lines of existing medical devices. But also there was a shortage of capacity and ventilators and capability. So Plan C is do it yourself because no one will do it for you. It's validation without regulation. So although that's the definition, here you see us after 10 extensive days of work with prototype number 3, like third generation of prototype that we presented to our health department. So we thought, yeah, if we could build this device in 10 days, we could score the local regulators and then send the device to the world. So after 10 days, we've released like 2 hours after this photo was taken, we've released our blueprints to the world in GitHub. So that's basically the device. It's inspired by the Ambo, the BVM bag that you can squeeze, as you've seen earlier. And later I'll show you how it works. But we understood that we need to make this mechanism as simple as possible. I'm electrical engineer, learned aerospace engineering, robotics, but I'm not a medical engineer. So how you close this gap? So by using a global partnership, and we opened 72 groups of WhatsApps. 40 of them is for the one per nation or state, and the rest of them 22 in our project. And we just use the collective consciousness and knowledge and their questions and answers to rapidly close the gaps of the development. So you can see on the left, we've assembled 3 groups of robotic mentors, and we've took it because time was of an essence. We said 3 is better than 1, so let's do a competition. But it wasn't a regular competition because the group that was got more recognition is the group that helped the other one to improve itself. So it was kind of awkward competition, but it was really, really different from what we've read of how Steve Jobs ruined Apple in its early days. And it's not the first time that we're doing this kind of approach, and it worked. So what you see on the left is the prototype of one team. And 3 days later, they were so fast, so they built the device on the upper right. And 10 days afterwards, you can see it working functional. As you see, you can change the rate and the squeeze depth, and also this machine is a pressure-based machine, which means you are measuring the pressure besides the patient mouth. So of course, as we are doing in the Israeli Air Force in the operational and maintenance startups, we're supposed to understand the operational concept of operation process. So you can see, except of this device, we are also using these pipes and BMs and other components that are already there in the hospitals. Here you can see the pressure sensor, which follows all the way to the mouth of the patient. And we've also developed a monitoring device. So practically you don't need it when you watch over the machine, but what happens if you are having multiple patients? So you can monitor 10, 9, 20 machines from a single point of view. So that was wonderful. I told you before that we had 3 teams. So after the first one was the quicker one, the second one helped the first one to improve its design and improve where we should locate the engine and how to improve the mechanism. And the third group shifted from developing the device into manufacturing prototypes, so we can send them for evaluation, for upgrades, for people to give their opinions. And then, okay, that's the specification of the device. It has both visual and vocal alerts. It can work without batteries, without the electricity, and only one single page was built according to the common knowledge of everyone, because this person sent us the MHRA standard for rapid manufactured ventilators, and then this one said, what about pig trials? Have you used it on pigs? So first we took it to Flex laboratories to measure everything that is, because we're engineers, we want to know what we have in our hands. We've took it to Ichilov Hospital, this is the monitoring device that we've developed as well. This is a calibrating device for ventilators. And because someone from Italy asked, what about pigs? So we said, well, why not? So we took we did Helsinki and we ventilated a pig, and it was a successful study. And I must say that the doctor that was conducting this experiment was greedy, so he wanted to make sure if he'll put the pressure on the high bar, if he could explode the pig's lungs, but there was a safety mechanism inside of the algorithm, so he kept the pig alive 3 times out of 3. So that's the pig trials. And there is this guy, Robert L. Reed. He's a doctor from Texas, and he spent all of his time in comparing other open source code ventilators. And by the time that we started, we've seen this table growing, and then we've learned from the difficulties of the other groups, what they are facing, and not only from within, the only 205 people, but also from abroad. And then after we've shown it to the healthcare department, then we've released it to the world. More than 40,000 people entered GitHub and started reviewing the code. We were rated the day afterwards as the leading solution in this category, alongside with Metronics, which are on the higher level of like their plan B. And after the 3rd generation, we said, okay, it's enough for a workshop, but if you want to make it something that would help in saving lives, we need to go on program number 4, which means more hardened with EMC, electromagnetic emission and radiant capabilities, with hardened electric board, the monitoring service that I've mentioned earlier. So that's that. And I'll stop the screen so you could see the demonstration. Oh, okay. No, I'm not in big, but you can see. That's the device, and you can change the rate. And it's written in Arduino, and the electronic board that we are developing also integrates in it some upgrades, so you can transfer this machine also to volume-based respirator. And by letting the people from the Air Force reviewing the code and getting into the details and the design, we've shifted it from a workshop device into something that can stand with the best ISOs that's possible, and that's what we submitted to the Israeli FDA.
David, your project is amazing, and in fact, it's so well documented. You already answered the question I had, so I had to prepare another one, which I think you may have an answer. So, your project has been tested, has been developed by many people. So, how would you advise other product developers? How should they go about getting their products and projects validated? So, or at least being guided by the administrations, like in your case.
So first, I forgot to mention, there are more than 150 groups that's working with us on the same WhatsApp group. So from 40 international groups, we have another one that collects all of them. Although it took us 10 days to develop the 3rd generation, and we've shared the blueprints in Solid, in the Arduino code, in a well-documented as possible. Is the fastest team took her to replicate the same device 20 days. So that amazed me because it's there. So what we did, there are already now 4 teams around the world that are in New Haven, Alaska, Singapore, and Guatemala that have completed their own exact or modified version, and which is great because they gave us a lot of feedbacks. And the reason that we've reached out, because we said at first, maybe our health department won't support us in this, in regulating the device, so maybe other partners in the world could succeed. But we had a good, we were surprised because the local FDA authority wanted to help us. And what we're doing is on a hourly, half daily basis, we are supporting all these groups around the world. We are sharing with them our problems, we're getting feedbacks, vice versa. I think one thing that is important, and we need to hack it as a worldwide community, is how we can create these kind of devices and using, well, not venture capitals, because venture capitals only support startups which are profit and not profit. So how can we create these funds for open source initiatives for non-profit organizations with the support of the world in order to make the technology be transferable?
Yes,